Alright, hi everyone, welcome to my YouTube channel, City of Elections. So in this video, we're going to talk about this project for Disco Strobe Light. Of course, still the Arduino Project Handbook by Markedis. So in this project, you apply the skills you learned in Project 3 to make a strobe light with adjustable speed settings. Now, when we say strobe light, we just mean this one will turn on, then turn off. This set will turn on, then turn off. Turn on, turn off. Turn on, turn off. Turn on. That's it. Just like this police siren, okay? And look at the way they designed it. Red, blue, red, blue. So on, off, on, off, on, off. But how fast? How fast does it change from on to off? How fast? What is the value? Now we are going to get that value from where? The potentiometer. So, please watch the previous video so that if you have watched the previous video, you'll be used to this potentiometer guy. So as we adjust this value here, we get what? We get a reading in the we get input reading, and we can map that value to any range we want. So let's just go into the connection, okay, and then to the program. Okay, so of course, input, then process, this will be processing, and then of course microcontroller Arduino, then output will be our LED, these guys outputs. So in the textbook, what in the book handbook, you see two red and then two blue, but I don't have blue, so I'll use green instead. So, and of course resistors, okay, resistors, and then jumper wires. Okay, so let's go. Let's make the connection. So let's just start from output this time. So this guy, output this time, and then connect this guy to the uh, microcontroller. Let's do that quickly. The center pin, of course, goes to inputs A0. We can use that for today. Let's use oh boy, let's use another pin for today instead of the usual A0. Let's use A1. Okay, and then for ground ground pin, GND, ground. So let me connect that here. Let me just put that here. Okay, ground, and then 5 volts live. Put that here. Sometimes I like to just put them here. So we have that here, just at the start, and this one here. So then the wires are not crossing each other. Okay. So we have our input sets. Then for the output, two of these guys. Which leg is this leg is longer? So let me just put this shorter leg inside this one, the neutral, okay, negative part, and this side. So let me put the LED. Okay, so we have them connected now. All right, we have them on the board now. So okay, now let's connect them to the input. So we are using one output. Let's connect them to the microcontroller. One output is controlling two LEDs, meaning let me start from pin 13. So you connect pin 13 to 1. Okay, connect pin 13 to 1. Then you are going to loop from that one. I mean, connect still in that one and loop to the other LED. Loop to the other LED. Are we clear with that? Look at what's going on here. Look at what's going on here. So I connected from one. Look at it. From one output pin, one pin which we will set as output, connected it here to this part of the breadboard. Look at it from this guy here. Now, of course, this one now, this part leads to light up this LED. But this same part, I loop from this part connected to this other part that lights up the same LED. I'll do the same for this guy. So there we have it. There we have it. And I think that's our final connection. Oh, I've not added something. I've only connected the, how this is funny. I've only connected the analog in. That's the input from the potentiometer. I've not connected the potentiometer to ground. So let's do that now. Sharply, sharply. So, of course, one side will go to the negative. Okay, so I'll go to negative. And this I'll go to positive. Good. And then even the LEDs too. This is negative. I've not connected that. So what we'll do is loop it from this negative which we have here. This negative. We just loop it to the side negative. Okay, so I hope that's clear. You can see this negative here. So this line, if you trace it down, it matches this negative. So you just loop. So this one now has negative, which matches this negative. Good. So that's the complete setup. Okay, so this is Strobe Lights program. Let's start writing. Strobe Lights program. Okay, let's see. Disco to it. Disco. Alright. So of course you know how we do this. We start variables. So our input is what? Potentiometer. Let me use this in potent. Something different this time. So A0 for potentiometer. And then our output is what? LEDs. So LED. We have a red LED. So let me say LED R, which is for red LED. Let's put that one in pin 12. Then LED blue. Let's put that in pin 13. Let's put that in pin 13. Okay, so I think we're done with this. So now let's set them up to output and input. For this one potentiometer, we don't need to set it to output, so we can just leave it like that. We do not need to set it to output or input, so we can leave it like that. Then for pin node LED, that's a red one, we can set down to output. And then same thing with this. Right, I think we are good to go. Then now for our loop, the part that's going to repeat for our loop First thing we do, we read the value from potentiometer, and then map that value, map the value, and then of course use the value. Okay, so when we read it, analog read, so of course, let's say that one is something different this time, and let's say delay, no, value. Why did I use value? Or let me say port value this time, port value. So the same thing here, int port value. Okay, then of course to map it to now listen to this map. So the port value, we are mapping the potentiometer value, and of course 0 to 1203. Now please watch the previous video so I don't explain the whole thing. However, this input from the analog pin is coming as what? 10 bits. Okay, the input is 10 bits. 2 raised to the power 10 is what? 200 and 1024. But from 0 to 1023 is 1024. Okay, so we are mapping that value, saying once you turn the potentiometer fully on, you are getting this one. So what is going to be the highest delay time? The maximum time that we are going to use as the delay is our choice. We can say 1 minute. This is 1000 milliseconds, the same as 1000 milliseconds is the same as what? 1 second, not 1 minute, 1 second. So we can say 0 to 1 second, meaning if you turn the potentiometer off completely, that means we are having 0 delay. So let's make our minimum, let's say this is small, 10, that is 10 milliseconds. That's small, which is wow, 0.01 second. That's small. Okay, 0.01 second. So let's just make it this, so it will be 0.1 second. Okay, so 1 second. So let's leave it at that. So now, of course, save our map value as let's say time. What's happening? Or let me use time. Okay, so we have to declare that here in time. All right, so we are set. Now turn on and off the LEDs. So we say digital right. So let's turn the red one on first, red LED high. Then we are going to do what? Delay. Normally we used to put the time, we now say this second, but we are not going to use this again. We are going to use what? Time, which is what? This is our mapped value. Now this is a variable time. It's a variable time. Now the thing is that this time will what? Correspond with this value, but this value with what? Is mapped to this value, and this value what depends on what? This one, which is what? This guy we are, hey, sorry, this thing should be what? Port value, because this one is the physical potentiometer. We are changing the value, and it will now affect the value that we have here. This value that we have here is what we now put inside this, which is what? Bearing from here to here, and we have mapped it to what? To answer, to work as from here to here as output. Okay, so meaning by the time we wind this physical pin, physical potentiometers, you wind this thing, you are affecting this, and there, and invariably, should I say invariably, and you're also affecting what you have here. Meaning, instead of writing this in 100 milliseconds. Only you come back to your program and change this one to 500 or change it to whatever. By putting time here, as we turn our potentiometer, the physical potentiometer, this value automatically is changing, meaning how long the LED switch between on and off to the that LED is changing as we adjust the potentiometer. We are adjusting the speed. Okay, I hope you understand. So now let me digital right, same red LED, we turn it what off, which is low. Okay, and then we delay for that time. Now this is for the red LED. Let me do for the blue LED and blue LED. So all here now will be blue LED, blue LED. Okay, so we are done. So time to run. Oh, sorry about this. While we're making the connection, we used A1, not A0. Okay, this one we should use A1. Okay, so you can see how they are changing. Now, if we change this value, okay, it's at the lowest now, so it's kind of fast. So we can actually increase it so that it makes it slow. The time at which they change now, it's higher, so it's kind of slow. So we can even increase. Now, note the maximum time depends on that our maximum there. So not to make this video longer, I think I would not change that. But there's one thing I think I can change to make us see more beauty in this. So instead of on off, we'll do it on off on off on off. Okay, we'll do that. Let's just do that quickly. Like saying, let me give space. So we can repeat it by saying on off. Okay, all this one is for red. On off on off. Then the blue will now do its own to be what? On off on off. Good. So that's that. All right, so you see the difference now. On, off. Oh boy. Okay, but you see the difference. I believe you can see the difference. I prefer this one that's very fast. Yeah. Okay, so that's that for this video. Like, share, subscribe, and I'll see you in the next video. Thanks for watching, and bye for now.